Even before it appeared in a production vehicle, a new inline six-cylinder engine from GM Powertrain was proving itself a winner. On July 4th, driver Larry Ragland captured the first-place overall spot at the 2000 Pikes Peak International Hill Climb with his Vortec L6-powered GMC Envoy. The grueling Pikes Peak gravel course is one of the most demanding in the world, starting at an elevation of 9,482 feet and finishing 12.42 miles and 156 turns later at 14,110 feet. Larry and his Envoy charged to the finish line in just 11 minutes, 17.66 seconds, a new record in the high-tech truck and sport utility class. Hello and welcome to GM Service Know-How. I'm Peter Carey. In this program, we're going to take a detailed look at the impressive new Vortec 4200. This engine will power the new generation of GM sport utility vehicles for 2002, namely the Oldsmobile Bravada, the Chevy Trailblazer, and the GMC Envoy. The Vortec L6 has been described as an engine for trucks with the technical sophistication of a premium passenger car engine. Let's take a look at why.
The Vortec 4200, RPO code LL8, produces 270 horsepower and 275 pounds-feet of torque. The inline six delivers more peak power and provides torque comparable to a larger displacement V8 while supplying better EPA fuel mileage ratings. A 10-to-1 compression ratio delivers the horsepower and combustion efficiency advantages of a high compression engine, yet allows the 4200 to operate at peak output on regular octane gasoline without knocking. The all-aluminum block and cylinder head are both formed using a lost foam casting process that allows more exact dimensional control. The process begins with a styrofoam pattern that replicates the part being cast. Loose sand is poured around the assembly and vibrated to fill its voids. When molten aluminum is poured into the sand mold, the hot metal melts the foam, displaces it, and cools in the exact shape of the part. As you can see from these cutaway block sections, the lost foam casting method enables oil galleries, coolant, and other internal passages that would otherwise require drilling or external plumbing to be cast directly into the block and head. The camshaft cover is formed from a composite plastic material that serves to deaden valve train noise and reduce weight. The cover is designed with its seals and fasteners retained, so the parts count is reduced compared to a typical aluminum cover. In addition to the main cover perimeter seal, individual seals are provided for each of the 6 ignition coil module openings. These seals should be replaced as a set. The composite intake manifold delivers similar advantages of reduced weight and better noise dampening, as well as improved airflow compared to conventional metal manifolds. The intake manifold is manufactured using a vibration welding process. A non-serviceable foam and plastic noise cover is attached. As with the cam cover, the intake manifold is supplied with captured fasteners already in place. The cylinder head features dual overhead camshafts with 4 valves per cylinder to maximize airflow. The valve train uses roller followers for reduced friction, which results in improved gas mileage. One of the most significant features of the Vortec L6 valve train is a variable cam phaser system incorporated in the exhaust cam sprocket. The cam phaser assembly is referred to as the exhaust camshaft position actuator in SI 2000.
The cam phaser system enables the PCM to continuously vary valve overlap to determine optimal performance, drivability, and fuel economy in all driving conditions. Let's take a closer look at how the system operates.
The central component of the cam phaser system is a hydraulically actuated piston located in the hub of the exhaust camshaft position actuator. Engine oil is directed through a solenoid control valve to the front and rear of the piston. This valve assembly is named the camshaft position actuator solenoid valve in SI 2000. The PCM sends a pulse width modulated signal to the actuator valve to adjust the volume of oil that's delivered to each side of the piston. The piston has an internal helical spline that slides in mesh with a gear. As the piston moves, the piston and gear mechanism changes the timing of the exhaust camshaft relative to the cam drive sprocket. When oil pressure is applied to one side of the piston, the cam moves clockwise and timing is advanced. When oil pressure is applied to the other side of the piston, the cam moves counterclockwise to retard timing. The total range of cam phaser rotation is 25 camshaft degrees. When the 4200 is at idle, the exhaust cam is in the fully advanced position for minimum intake valve overlap and exceptionally smooth idling.
As we've said, exhaust cam timing is continuously varied by the PCM under other engine operating conditions. Using input from the camshaft position sensor and various other sensor inputs, the PCM adjusts exhaust valve timing by sending a pulse width modulated signal to the camshaft position actuator solenoid. By monitoring and comparing the camshaft position and the crankshaft position signals, the PCM can determine that the actual cam phase angle is the same as the value it's commanding. We'll look more at this feature a little later in the program as we cover the ignition system with the other engine controls. In operation, the exhaust camshaft position actuator effectively functions as an internal EGR system by using valve timing to reduce NOx and hydrocarbon emissions. On a related note, the camshaft position actuator valve has screens to help eliminate contamination in the oil supply. However, to ensure optimum performance of the system, it's important to change engine oil according to the recommended schedule. You'll find much more detail about the variable cam phaser system in an IDL program on the subject. Now, let's continue with our overview of the 4200 engine's mechanical features.
The inline-6 crankshaft is considerably longer than a typical V8 or inline-4 cylinder engine crank. The crank is formed from durable nodular iron using a refined casting process. A dual-frequency crankshaft damper is employed to help resolve torsional vibration. The damper's 3 steel discs and rubber rings counteract inherent crank flex. A bearing beam or ladder connects the 7 main bearing caps. This bearing beam structure combines with the engine's deep skirt block design to increase stiffness and reduce engine vibration. Connecting rods and caps are forged powdered metal, so care must be taken to ensure mating surfaces are not damaged during service procedures. The pistons and rods use floating wrist pins.
The Vortec 4200 oil pan is another example of powertrain's extensive efforts to minimize noise and vibration in this engine. The oil pan bolts to the transmission bell housing as well as the engine block. This eliminates points of vibration and makes the complete powertrain act more like a single casting. The oil pan is engineered to provide pan-axle four-wheel and all-wheel drive capability. A dry passage cast through the width of the oil pan allows a drive axle to pass through it rather than under it. The passage allows for a more compact powertrain package, and the engine can be placed lower in the vehicle. This lowers the center of gravity for improved vehicle handling dynamics and also gives designers greater styling flexibility. Let's look now at the Vortec 4200's control systems.
The fuel rail is stainless steel and features the latest generation Multec 2 injectors, which provide consistent and precise fuel delivery for increased efficiency and reduced emissions. They are also lighter than the previous generation and feature a durable stainless steel director plate to finely atomize the fuel spray. In keeping with GM's most recent electronic ignition technology, the Vortec 4200 features a coil-on-plug ignition system. This provides the highest energy spark and the most precise ignition timing. an integral coil driver module is provided for each of the 6 cylinders. Each coil has a power feed, a ground circuit, and an ignition control circuit. The use of individual coil drivers allows coils more cool-down time between firing events and increases the available coil saturation time. The mounting bolt acts as a redundant ground path. Platinum-tipped spark plugs are used for maximum performance and durability. The 4200 PCM mounted on the intake manifold is an advanced Tech 2000 with 3 65-pin connectors. The PCM includes an internal knock sensor module. The Vortec 4200 uses 2 knock sensors mounted at the front and rear on the intake side of the engine block.
As with other ignition systems, the PCM uses crankshaft and camshaft position sensors for precise ignition and fuel delivery timing. The crankshaft position sensor is mounted in the left rear side of the block. The reluctor wheel on the crank has 6 equally spaced notches and a sync notch. The camshaft position sensor is mounted on the head near the camshaft position actuator solenoid valve. As we've seen, the cam sensor reluctor ring is actually part of the hub of the exhaust camshaft position actuator. The camshaft position sensor sends a 6-time signal plus a sync signal to the PCM for each revolution of the camshaft. Using the combined signals for the crankshaft and the camshaft position sensors, the PCM can determine engine position with great accuracy. If either the crankshaft or camshaft position sensor signal is lost for any reason, the engine can run normally using the remaining signal alone. Of course, the mill will illuminate to indicate that a DTC has been set. The Vortec 4200 uses a new electronic throttle control system. It's similar in operation to the system used on late-model GM vehicles, but there are some differences in the components. The throttle actuator control, or TAC system, eliminates cable linkage from the accelerator pedal to the throttle body and actually provides better throttle response than the typical mechanical system. And since there's no mechanical linkage to bind or brake and no cable adjustment is required, electronic throttle control is also more reliable. All throttle movements, including cruise control functions, are handled electronically by the PCM. The PCM receives input from 2 accelerator pedal position sensors contained in a single module, which is part of the accelerator pedal assembly.
A throttle position sensor is mounted on the throttle body assembly, as is the motor that moves the throttle blade. The accelerator pedal position and throttle position sensor are wired directly to the PCM. This eliminates the serial data circuit and separate TAC module, which are used on other electronic throttle systems. The PCM controls the motor actuator with a pulse width modulated signal. The PCM has an ignition voltage input that's dedicated to the TAC system. Because of this new circuit, 2 additional codes were added to the DTC list.
The cooling fan used in 4200 engine applications is a new electronically controlled viscous design.
Although the fan is belt-driven from the engine, its speed is controlled by the PCM. This is achieved through the use of a viscous clutch. Based on information it receives from various sensors, including a fan speed sensor, the PCM uses a solenoid to operate a fan control module.
The complete service procedures for the Vortec 4200 will be provided in service information. In this program, I'll just cover some of the features you should be aware of when you perform service operations on the engine. Let's begin with a look at the special tools you'll need.
Special tools used for the Vortec 4200 include a specific engine lift bracket, J44220, a camshaft holding tool, J44221, and a cam phaser and sprocket holding tool, J44222. Then there are front and rear cover alignment pins, tool number J44219, a pilot bearing installer, J44224, and a front hub holding and removal tool, J44-226. This tool is used to hold the hub when removing the crankshaft damper. There's also a rear main seal installer, J44-227. The seal is supplied with a plastic insert that holds the seal in position during installation. The insert comes out as the seal is pushed home with the installer.
Tap around the installer to confirm that the seal is seated and flush with the housing. You'll find details on the other tools you'll need for unit repair in service information. The Vortec 4200 makes extensive use of sealant. For an example, let's start with a look at oil pan removal.
Before removing the oil pan for service, it's important to remove the oil level sensor first to avoid damage to the sensor. Ensure that all of the oil pan bolts are removed, including the 2 bolts at the rear, which are below rubber plugs when the engine is in the vehicle. When all of the bolts and the 2 nuts are removed, use 2 of the pan bolts as jack bolts in the threaded holes provided to break the seal between the pan and the block. Never pry on the oil pan. Use a plastic scraper tool to remove the old sealant. Do not use abrasive pads or motorized grinders. The pan is assembled to the engine using a 3mm bead of sealant. Use only the correct 3-bond sealant, GM part number 12378521. Do not use any other type of RTV or sealant. A standard caulking gun is required for applying a 3mm bead of sealant to the oil pan rail of the block. Use the nozzle supplied with the sealant. Remember, too, that parts must be assembled within 10 minutes of applying the sealant. The 2 mounting studs on the block can be moved to whatever positions you find most convenient for oil pan installation. Remember that the timing chain must be installed before installing the oil pan.
Here's another quick tip in relation to oil pan installation. As you can see, there are baffles in the bottom of the oil pan. When installing the oil pan, you'll need to maneuver the pan to clear the oil pump and screen assembly. Because of the considerable weight of the pan and the maneuvering that's necessary, we strongly recommend that you apply the sealant to the block rather than the pan. This is especially true when you're replacing the oil pan on the vehicle. Also, when installing the oil pan off the vehicle, it may shift a little to the front or rear. Use a straight edge to ensure that the pan is flush with the rear of the block. This is necessary to avoid possible misalignment problems between the engine and the transmission. Now, let's move on to the engine front cover.
The water pump must be removed before removing the cover. Also, the front cover has a bolt in its center for additional support. It's important to remove this bolt before removing the other cover fasteners. Otherwise, the bolt can be difficult to loosen. As with the oil pan, jack bolts are used in the threaded holes to break the seal for easier removal of the front cover. The same jack screw procedure is also used to remove the crankshaft rear oil seal cover.
As with the oil pan, a 3mm bead of sealant is used around the sealing surfaces of the front cover. It's very important that this sealant is applied correctly to maintain separation of oil and water in the 4200.
Use the trace grooves on the front cover as a guide for applying sealant, and again use only the correct part number 12378521. Apply sealant on the inside of these 3 bolt hole bosses on the cover before assembly. When installing the front cover, alignment pins J44-219 are used to position the cover correctly before the sealant is pushed into contact with the block. The crankshaft rear oil seal housing is also sealed with a 3mm bead of sealant. The rear oil seal housing is installed using the same alignment pins as the front cover to position it on the block.
There are no coolant drain plugs on the block, but it is possible to drain the coolant through the heater outlet. Still on the cooling system, the thermostat is in the inlet housing. The housing is assembled to the block with an O-ring. The thermostat and housing are serviced as an assembly. Now, let's take a look at the timing chain installation procedure for the double overhead camshafts.
Every seventh link of the Vortec 4200 timing chain is darkened to aid the technicians in aligning timing marks. Before the timing chain is installed, the tensioner components must be installed on the block. These are the tensioner guide, and the shoe. Now install the camshaft holding tool, J44221, with the cam flats up and the number 1 cylinder at TDC. Compress the tensioner and lock it in place. Then install the crankshaft sprocket on the crank. Position the intake cam sprocket in the chain and align one of the darkened links up with the timing mark on the sprocket. Then feed the chain through the opening in the head. Next, install the intake cam sprocket onto the camshaft. Install the intake cam sprocket washer and bolt and tighten the first pass to specification. Install the chain on the crankshaft sprocket, again aligning the darkened link with the sprocket timing mark. Now install the exhaust cam position actuator into the chain and align the darkened link on the chain to the exhaust sprocket's timing mark. It may be necessary to rotate and hold the camshaft to align the pin to the camshaft sprocket. Install the exhaust cam sprocket washer and bolt and tighten the first pass to specification. Use a torque angle meter for the final pass and rotate the bolt to the angle specified in service information.
You'll notice in the service information, a torque angle meter is used extensively to ensure accuracy when tightening crucial fasteners such as the cam sprocket bolts on the 4200. Another good example of a crucial fastener would be the crankshaft damper bolt. Be sure to hold the rear of the crank to achieve the proper torque when tightening the bolt securing the damper. When performing this procedure on the vehicle, you can access the torque converter 15mm bolt to attach the crankshaft holding tool through the access opening provided on the block. As always, it's also important to thoroughly clean all fastener threads before reusing them. And that completes our GM service know-how on the Vortec 4200. I'm sure you'll agree the engine should be a winner with GM Sport Utility customers. For additional information, be sure to see the book that accompanies this video. It covers all the information we talked about, plus additional specifications and diagnostic information. The instructions for taking the test are coming up next. As always, thanks for watching. For GM Service Operations, I'm Peter Carey.
All testing for the GM Service Know-How program is now accomplished through the GM Service Technical College website. The interactive voice response system is no longer active. To receive credit for this course, please access the GM Service Technical College website at www.gmstc.com and select Training Management from the menu. This will take you to the Training Management System. A valid username and password are required for this portion of the site. Once you have been granted access to the system, select the Tests option. From here, you will be presented a list of available tests. Select the test you wish to take and follow the prompts. This testing procedure provides immediate results at the completion of the test and is linked to the GM Service Technical College Training Management System. Your opinions and suggestions are welcome as a way to improve future GM Service Know-How releases. A survey form is available at the end of the course test.